In this tutorial video, we will be learning on 2x2 Hermitian phase estimation. We will be doing the coding on Google Colab. Like we did in the previous video, we will be starting with the installation of Bluecat. Type the code, !pip install Bluecat in order to install Bluecat. Let us do it in Google Colab. Type the code that was shown earlier. And click on the play button to run the code. Bluecat will be installed after a while. Then go to Edit tab and select Notebook setting. Enable the GPU and save the setting. Firstly, we will learn on quantum phase estimation of random Hermitian matrix. In previous tutorial, we have calculated the eigenvalues of matrices of the ZAT gate and the X gate. This time, we will perform the quantum phase estimation of a random generated 2x2 Hermitian matrix. Calculating eigenvalues of Hermitian matrices is useful for finding physical quantities in quantum mechanics. It has wide range of applications in fields such as quantum chemistry and quantum simulation. Next, we will learn on quantum phase estimation of Hermitian matrix with eigenvalues summing up to 0. The general idea of quantum phase estimation for Hermitian matrices is the same as previous one. In the previous tutorial, we just prepared controlled ZAT gate and controlled X gate for estimating ZAT gate and X gate as controlled U gate. However, generally a Hermitian matrix is not a unitary matrix. Therefore, we cannot prepare controlled U gate directly. Just to conclude, we need to prepare controlled gate as controlled U gate for the Hermitian matrix H in the quantum circuit, which gives an eigenvector of H. By using these circuit and gate, we can perform quantum phase estimation and obtain the eigenvalue. Here, we consider the quantum phase estimation of a unitary matrix. Keep in mind that U is a unitary matrix. Then we will prove that the eigenvector of U is the same as the eigenvector of H, and find its corresponding eigenvalue. So, we can obtain the eigenvalue of H by the quantum phase estimation of this equation. So let's go to the implementation. First, we import required libraries. In this time, we use Numba backend, and check the version of Bluecat. Next, we make a random Hermitian matrix. Type the codes. The first method is to check whether the mat is Hermitian or not. Then next, method is to get circuit to unitary and convert to NumPy matrix of a unitary matrix U3 of theta, phi and lambda. Then next, the method to make random Hermitian and return the triplet of Hermitian, eigenvalue and parameters for U3. Then, we will make a Hermitian. Type the code. After running the code, we will get the random Hermitian of theta, phi and lambda. Then, we can make an eigenvector using theta, phi, lambda and U3 gate. Then, check HVEC is equal to EVEC. It means, EVEC is a pair of eigenvalue and eigenvector of H. The preparation is done. We will implement quantum phase estimation. We make the quantum circuit and calculate E by quantum phase estimation. Next, type the codes. The first method is to add inverse quantum Fourier transform operations to the qubits of the circuit. Then next, the method to prepare an initial circuit which gives eigenvector. Then next, the method to append controlled gate U to the circuit and make controlled gate U by using eigenvalue. Then next, returning quantum phase estimation circuit from eigenvalue, parameters of U3 gate and a number of binary digits of phase estimation. After that, install the libraries of Qiskit and PyLaTeX Inc. Then, let's see the quantum circuit of quantum phase estimation. Type the code and after running the code, we will get the circuits of quantum phase estimation. Then, we make a function for calculating the eigenvalue from observed result. Next, type the codes. The first method is to run the circuit for quantum phase estimation and returning candidates of eigenvalue, and then next method which converts the measured result to floating point value. Now, we can perform the quantum phase estimation. Let's see the result. Type the codes, we print the expected value and run small to high precision for comparison, and display a number of observation of obtained eigenvalue and a deviation from true eigenvalue. After running the code, we get the values nearby the true eigenvalue. Next step is to create quantum phase estimation of Hermitian matrix without eigenvalues summing up to 0. First type the codes. This method is to make random Hermitian matrix and return Hermitian matrix, a pair of eigenvalues and parameters for U3 gate. Then next, we will be making Hermitian matrix to get the random Hermitian of theta, phi and lambda. Then next, type the codes. The first method is to modify and consider the phases for eigenvalues. The second method is to modify the quantum circuit for using the arguments in first method. Then, let us calculate the first eigenvalue. Type the codes. Firstly print the expected value and run small to high precision for comparison. Then to display a number of observation and obtain the eigenvalue and a deviation from true eigenvalue. After running the codes, we will get an eigenvalue by modifying controlled U gate. Next, we consider to obtain another eigenvalue. Another eigenvalue can calculate by quantum phase estimation with another eigenvector. Let's implement it. Type the codes. The first method is to make an initial circuit which prepares second eigenvector. Then, the second method is to modify for using the initial circuit and apply the controlled U gate. Then next, type the codes. We will print the expected value and run small to high precision for comparison. Then to display a number of observation, and obtain the eigenvalue and a deviation from true eigenvalue. After running the codes, we will get second eigenvalue also. Thank you for watching this video.